Couple of problems in homework 3.2, so I think I'll go ahead and jump on in here. We'll look at the first question. Here we have again a two-way table where what's happening is the person who gathered this data observed whether people report female or male in gender, and then they asked them what their favorite type of video game is in terms of the rating of the game. So you can see the outcomes here based on gender and rating, and just tallies altogether 646 people in the study. Okay, so we're just going to quickly go through and do these computations. So the first is the probability that somebody's rated T. And if you look at the rated T, that's just this column, and it's 304 people out of the 646. So we just have to do that real quick on the calculator. 304 divided by 636 is that 0.47798, etc. And the rule for rounding should be 3 significant figures here, which means you start counting at the first non-zero digit. So 0.477, this 9 makes the 7 go up to an 8. So I'll do 0.478 for rated T. Okay, and then I'm going to do rated M altogether. That was 208 people out of 646. Oops. Okay, so 0.322 is what I'm going to have to round with 3 places here. That 9 makes us go to 0.322. Okay, now rated teen and female. Don't use the multiplication rule. Just recognize it's 164 people that are rated teen and female. So 164 divided by 646. Okay, so 0.254, I guess. Okay. Now rated M and female, so here rated M and female is 50 people. Okay, so we'll just do 50 out of 646. Okay, so it's 0.0774. Remember, we don't count leading zeros. So start at the first non-zero digit, 774. Okay, so put that down here. I'm sorry, rated M and female here. Okay, so that all looks good. Okay, now this is a conditional probability. So here it says, what's the probability that it's rated T given that's a female? So if it's given that it's a female, you're only looking at these people. And now altogether, so that restricts a row or a column in your table. So if it's given that it's a female, for rated T, there were 164 out of 272. Oops. Like that. And so 0.603 is what we'll do here. Okay, and now this one also has a condition. It's still given that it's a female. Again, that vertical line is read given that. Okay, so what's the probability of a rated M given that it's a female? So again, we're looking at the females here, and for rated M, it's just 50 out of 272. So I'll go ahead and calculate that. Okay, and 0.184 on this one. Yeah. And then rated teen or female. Okay, so this one's going to be a little harder. The females all together here, there are 272. Okay, so but I need to take that 272 and I'll put it in over here, 272. But it's also, we want to count rated teen. So there are 140 T that weren't counted. So I'm going to have to toss in the 140. Okay, and so altogether that's 412 people, and it's out of the whole group, out of 646. So I'll just say divided by 646. Takes that last answer and divides. So that's the 0.638, I guess I'll put in. Like that. Okay, so rated M or female. Okay, so for the rated M, well, again, we're working with females still. So I'll look at the females. And then there's 100. So again, that's 272 females. So let me just add that in. 272 females. Plus, there's some rated M's that aren't females. So there's 158 of those. So we'll say plus 158. Let me just double check what I'm doing here. We're doing rated M or female. So we got the females plus the rated M that's not a female, 158 of those. All right, so we hit enter. That's 430 people out of 646. So divided by 646, enter. So 0.666. There you go. Okay, and rated T and male. Well, here, that's only 140 people that are in rated T and male. So it's going to be 140 divided by this total of 646. Okay, so that's 0.217. Okay. And then rated M and male. Okay, so rated M male, that's the 158 people here. So the and problems are a lot easier than the or. So 158 out of the group, the total group 646. Okay. So that's 0.225. Like that. I did that wrong. 245. There. That's good. Now we're continuing. I'm starting to run out of space, but here, rated teen, given that it's a male. So if we're only looking at the males, rated T, there were 140 out of 374. So over here, 140 divided by 374, enter. So that's 0.374 down here with the condition, 0.374. All right, now rated M, given it's a male. Again, we're only looking at the males. And how many rated M? 158 out of 374. So here goes, 158 divided by 374. So 0.422. Okay, now this is, I hate the or problems, but here they come. Rated T or male. Okay, so looking at the males, that's 374 people, but then you also want to count the females, 164 of them that are in the rated T because we have an or on this. So again, 374 males, oops, plus the females. So females that are in rated T was 164. Again, it's rated T, where is it? Rated T or male. So 374 males plus 164 females that like rated T. So 164. Okay. Out of the group, so you're going to divide that by 646 here. And so here we're going to get 0.833, I guess. Okay, now rated M or male. I guess I'll count the males again. So the males have 374, but it's or rated M here. So we got the males, 374. Let me put those in. Okay, plus the females that like rated M. There's just 50 of those. So we'll just say plus 50. So altogether, that's 424 out of 646. We'll just divide by 646. And so altogether, 0.656 on this one. Okay, now these are easy. Probability of female. Well, there was 272 females. Okay, so 272 divided by the total of 646 people. 646, enter, so 0.421 for that one. And then the complement, the rest of them should be the males, but and that's going to be about 67% or something like that. So we'll take a look. For the males altogether, it's 374 out of 646 that are male. So again, 374 out of 646, and that's 57.9%. Okay, so I'll put that in here, 0.579. Just going to look at it for a sec to make sure everything looks okay. I think everything looks pretty good. Now, I will fix anything that's wrong here. I had a lot of chances to make mistakes just now, so I'm going to check. And I got one bad answer. So the rated T here should have been 304 altogether out of 646. 304 divided by 646 is 0.470, and I did 478. So let's fix that to 470, and then hopefully everything's should have been 0.471. So, oh my God. So 0.471 is the correct answer here, and of course we get that down here. So clearly with the 5 in this fourth place, the 0.470 should have been rounded to 471. You can see that here as the right answer. So I just totally blew that one. And then we're going to do, again, this whole issue of whether being rated M is independent of gender. So right now, we're going to just compute the computation here for rated M. Was 0.322, so we're going to multiply that, 0.322, and then times the probability of male. Okay, so for male, that came out to 0.579. Okay, and I'll just hit enter there. So that rounds to 0.186. Okay, now for these to be independent, the probability of being rated M and male should be the product of these two numbers, which I did up here. So rated M and male up here was 0.245, and that's different from 0.186, which is probability of being rated M times probability of male. Because those are not equal, the events have to be dependent. Okay, so check my answer. It should be all good. Yeah, everything's great here. So apologize about the mistake. Again, that should have been 0.471 because I rounded wrong. Felt pretty good about everything I did until I screwed that up. Anyway, that's all I'm going to do. I'm not going to fix it. One more problem here. This one's question 3. I don't know if it's going to randomize the answers or not, but on question 3, it just we're going to have to do the multiplication rule on this one. So it says, suppose a room contains 20 women and 42 men. So that's 68 people altogether. I'll just do that over here. So 20 plus 42, just to have record of this. It's 62 people altogether. Now 5 of them are going to be selected randomly without replacement. Now we want the first 3 people to be women, and then the next 2 would be men, and they want us to basically do the probability. Now we have a lot of 5 things happening, and that's going to be 5 individual probabilities, and they all have to happen, each and the next and the next and the next. So what you do is you just multiply all these probabilities. So for the first person, it's got to be a woman. The first 3 are women. So there are 20 women. So initially there's 20 women out of, what did I say, 62 people? That has to be a woman. The next person has to be a woman also. So I'm going to multiply by, now there's only 19 women left out of 61, like that. And then the next person, also a woman. So there would only be 18 women now out of 60 people. Out of 60 people now. Okay, now the next 2 have to be men. So there are still 42 men. So I ought to be able to say, all right, so there are 42 men to choose from, but there's only 59 people left. So, oops, I'm going to go down and say that's out of 59. And then 1 more person to pick also needs to be a man. So there were 42, now there's 41 men out of 58 people. Okay, so that's 5 different probabilities multiplied because all 5 things need to happen, and there's only a 0.015, we'll say 2 probability of happening. 0.0152, like that. Check my answer, should be okay. And then they say, well, what would be the answer if all people were chosen with replacement? So on this one, what's going to happen is you're going to start with 20 women out of 62, and every time you pick someone, you're going to replace that person. So the number of women won't change and the number of people won't change. So I'm going to clear that and just go ahead and say, all right, I need 3 women. For the first, there's 20 out of 62. Okay, and then the next person that's chosen. Well, you put the first person back, so there's still 20 women out of 62 people, and that's all that's really happening here. You're doing it 3 times, and every time there's still 20 women out of 62, like that. And then now we have to do the men. So with the men, there are 42 of those, so I'll do 42 men out of, and we keep putting people back. There's still 62 choices. Okay, and we do it one more time. We want 1 more person that's going to be a man. So there's still 42 men because we keep putting them back out of 62 people. And hit enter. So it's a 0.0154, just a slightly different answer. And I guess the lesson to be learned here is that whether you do replacement here, or here, the second one was with replacement, first one was that without replacement, the probabilities are still basically the same thing. It doesn't really matter that much. Anyway, that's it. I mean, in other contexts, it might matter more, but not on this problem. Okay.